Right, gentlemen, we have the prime position right after break, so everyone's attentive and listening into this exciting conversation. So before we jump into 5G and ports and all the great advantages, let's take a moment just to introduce ourselves, a little bit about who you are, your role, and then some initial thoughts you might have. Hugh, do you want to go first?
Yeah, so my name is Hugh Gallagher. I'm Director IT Services for Carrix, which is the parent company of SSA Marine. We are a global marine, rail, and cruise operator. I've been involved in technology for most of my career. The company was founded here in Washington about 70 years ago, and I'm happy to kind of discuss some of the initiatives that we have ongoing.
Excellent. Thank you, Hugh. David?
My name is David Letterman. I work with Nokia, so Finnish company. Nokia makes private wireless networks, so private LTE, private 5G networks. We have about 50% of all the networks globally deployed, private wireless networks. And I work for a group specifically called NDAC, or Nokia Digital Automation Cloud. So it's a full end-to-end managed service where you deploy using Nokia's regular carrier-grade radios to cover campuses of any size, so seaports, for example. And then we have industrial devices for people to be connected or to connect legacy machinery. And then we put on-premises an ecosystem-neutral server that can run the 5G or 4G core, as well as other ecosystem-neutral applications that are specific to that industry. I've been with Nokia for about 25 years, and I've been doing this for about 8 years. I'm based in the Bay Area.
Excellent. Thank you, David.
Thanks.
Mikko.
Hello, my name is Mikko Jarva. You probably hear from my double consonant name that I was born and raised in Finland. I've been expatriate for last 20 years and nowadays based in Santa Clara, California. Very honored to be here. It's been a great program so far and very interesting topics. Hopefully we make one as well here.
Excellent. Thank you, Mikko. And Harri.
Yeah, so my name is Harri, Holma, and I'm working at the Nokia headquarters in Finland in the technology office and working with the 5G connectivity solutions. And indeed happy to be here, part of the panel discussion today.
Excellent. And then Harri gets the award today for traveling the farthest distance to be with us. So Harri, thank you very much for that. So let's start with the voice of the customer, Hugh. There's been a lot of chatter, positive, about the implementation and use of cellular networks inside port operations for a whole host of use cases and reasons. You've all been leading the agenda here in the Pacific Northwest, first deploying a private 4G LTE network at the Port of Seattle, and now just recently with Husky. I'd love to get your perspective on why cellular and wireless is really important in the maritime industry.
Sure, it's a great question. I guess the origin story of our relationship with Nokia starts with our desire to replace aging and somewhat problematic conventional wireless networks. And so we're looking at kind of 4 different value streams. First being health and safety. So improved connectivity and data throughput is allowing us to integrate more advanced collision avoidance, inventory management systems, which help to ensure that all of our employees get home safe every night. So that's kind of the first big one. The second is around security. So we know that working with Nokia will ensure that we can maintain kind of a robust cybersecurity posture as it relates to wireless connectivity. That's a big one in the industry and across all industries right now, of course. The third, I would say, is around environmental. So with increased access to data and analytics, this is furthering our efforts to reduce idle time, equipment idle time, reduce what we call truck turn times, or the amount of time that vehicles need to stay on a marine terminal. This reduces carbon emissions and helps ensure that we are making optimal use of the energy resources that we consume, whether it's carbon-based or clean.
Yeah.
And then finally, service. Again, increased access to data and analytics will help further our efforts to improve the transparency in our segment of the supply chain, ultimately improving that customer experience for our supply chain stakeholders. We all lived through the pandemic and kind of saw, what happened to the supply chain a few years ago, and that's a big topic of conversation in our industry. So those are kind of the 4 big ones.
Yep. And these are unique, David, to the maritime industry. As you mentioned, you've been in the cellular world for a long time, but in private for the last 8 years at Nokia, and you're seeing similar patterns across different industries. I'd love for you just to touch on how similar are Hugh's experiences to other industries and why is cellular becoming important?
Yeah, so for those use cases, it's pretty, I'd say, identical across industries, right? So most of the companies that we sell to are heavy asset industrial enterprises. So they all have in common some challenge with their existing connectivity, whether it be the Wi-Fi, the wired Ethernet, or whatever the public cellular carrier might offer them. So it's seaports, it could be airports, manufacturing, underground mines, open pit mines, you name it. They all have some challenges with what they're trying to do today for all those use cases that Hugh just mentioned, right? So to have better connectivity enables you to improve your operational efficiency and improve your connected worker and improve your safety, improve your sustainability. But then as you start looking towards more of your digital transformation, modernization, then you have to get into how can you connect everything pervasively? How can you have sensors on all of your machines so that you can really create that digital twin? Now you can get into real predictive maintenance. Now you can get into not just knowing what machine I have by its SKU that you purchase from the manufacturer, but what is this machine at my plant? What are the processes to keep it running smoothly? And you have the folks on hand, on site, that know the instructions to how to keep everything running smoothly, and they have access to all the experts. So you can really start getting to that Industry 4.0 goals that all these heavy industries are looking towards. So it's right now fixing it, and then very much a future-oriented strategy.
I think it's also safe to say that cellular is not just a flash in the pan in the enterprise. They're actually really taking it serious now and it's becoming more mainstream in their enterprise IT expenditures. Is that a fair statement from what you're seeing?
Absolutely. I mean, here in the States, we're lucky to have a technology that democratizes the spectrum itself. In most countries, they don't have that, so you still have to deal with the expense of getting access to the spectrum. So when we first started doing this 5-6 years ago, the spectrum, I'm referring to this thing called CBRS, but the spectrum itself wasn't even available. The technology wasn't really there. Most of our conversations were about that, the technology. Now everybody knows what private wireless is. They know private LTE, they know private 5G, they know the applications and the benefits of it. So I'd say that the conversation is dramatically different over the last couple of years.
Mikko, the conversations for private and specialized networks and big telco networks, and Harri will get to that in just a moment, have even fundamentally changed beyond yesterday's cellular networks. Nokia has been leading the industry in network as code, which essentially is transforming the network into an enterprise-ready, developer-friendly environment to go build new applications, new services, new use cases. Can you share a little bit about that push into network as code and why it's so important for specialized networks and networks in general going forward?
Yes, for all intents and purposes, telecommunication is largely utility and highly regulated. That means that while, of course, the bit transfers and all that in the networks are digital, the digitalization or the consumability of the network hasn't caught up yet.
Yep.
Now, what we see is that the next generation of the applications have a high dependency of not only running on top of the networks, but being able to shape the network for their purposes and being also very much network aware. Our initiative called Network as Code, we want to bring the control and awareness of the networks all the way to the developer ecosystem so that we can foster innovation and value creation on top of the networks like it hasn't been able to be done before. And there's definitely a demand also for from multiple applications that require to consume network in a different way. For example, network supporting worker safety, remote operations of equipment in the dangerous places. Those are some of the examples. Of course, then green deliveries using electric vehicles or even drones. That requires network specialization, and then autonomy or remote control of equipment and so forth. These are all the applications that require consuming network in a different way, and we want to enable it and most foremostly foster the innovation for developer ecosystem to take network into a different kind of use. So that's what network is about.
That's fundamentally different from what we had seen play out in the 4G world, where primarily a lot of that developer value is created and run over networks, not necessarily on them.
Right.
In the 5G era and looking forward into the 6G era, that's changing quite a bit.
Indeed, and my namesake Mikko Hautala, the ambassador, made the comment that typically any bit that goes through a network goes through a couple of Nokia equipment on the way to Google data center or something like that.
Yeah, right.
Now that's the traditional way of the network, so they've been actually configured and built to support that, mostly actually downloading things from the cloud to the devices and so forth. But with the emergence of the new type of applications, autonomous applications and so forth, we need to change that paradigm or so forth. So we want to make sure that those bits and bytes still go through the Nokia equipment, but how do they go through that is very much more controllable and shapeable, and it serves the application. So ability to deliver immersive video through the network, ability to have the network provide sensing of the environment and awareness of the application, that kind of things.
That's a very good point, Mikko. It fundamentally not only changes that developer relationship that didn't prior exist today, but it also fundamentally changes the relationship that carriers have with the ecosystem, both on the developer side, but also on the enterprise side as well. So Harri, that's actually putting some good pressure on an industry that has primarily put SIM cards into devices and forcing them in a good way to think differently about the value of their network. So how are partnerships now transforming amongst the telcos with ecosystems and now even with the enterprise in private 5G?
Yeah, that is an interesting area because there's a clear need for close collaboration between telcos and the technology providers. And the simple reason is ecosystem and scale. Remember that there are more than 1 billion 5G users, smartphone users globally. There are more than 5 million 5G base stations globally. And now the beauty here is that the very same technology, the very same connectivity solution can be used now also providing reliable, secure communication for the critical applications in the industries. And there's also a benefit in harmonizing the solutions. I think earlier there used to be multiple different connectivity solutions for the local areas. Wireline, wireless solutions. And there also used to be another solution for connecting the devices when outside the local areas. Now with the 5G, you can use the same radio connectivity for multiple applications in the local areas and also connecting the devices when outside the local areas. Now there are two maybe extreme solutions how to provide the connectivity. One is that the industry can provide or can utilize the public network for the communication, like public safety, for example. They have a dedicated slice out of the public network providing critical communication. Another extreme is that you have a dedicated local network that has no connection with the wide area telcos. But I would say what is becoming more typical is some kind of integration between those two. Using the same technology, having some private network for the local requirements. It could be like harbors, could be airports, could be mines. And then also integrating that solution with the wide area network. So clearly, there is a major potential for the collaboration between the players here.
Yes, and that, as you pointed out rightly, it fundamentally changes the economics for carriers now because they have a much bigger play, and their networks actually transform as well. Looking forward, Hugh, now that you have access to a private network, essentially you have the cloud at your doorstep. What are some of the sort of the big initiatives that you're looking forward to exploring and eventually implementing to help with your operations longer term?
Well, most of them relate to improved access to data and analytics, as I kind of discussed. But we're just not as worried about saturating our networks as we integrate new technologies. Whether that's helping us optimize the marine terminals, again, improve transparency, bolt-on safety systems, security, things of that nature. But I guess one of the biggest benefits that we're seeing is just around the partnership with Nokia. Historically, in the early 2000s, our engagements with other providers of network technology were more transactional in nature, and we were kind of left to our own devices to figure out how to adapt these networks into our industrial environment, where there are large canyons of steel, large STS cranes, and it was a challenge. Nokia is interested in the port and terminal industry. I mean, there's obviously a commercial aspect there, but they've showed a market interest in our industry in helping us think through how we can leverage this technology to the benefit of the supply chain. And we get access to all of the knowledge and experience that Nokia has gained over, 150, 160 years. So yeah, it's been a great, that's really the big aspect that we're seeing, is that partnership and helping us think in new ways and explore, where we can take this technology. So,
Absolutely.
Yeah.
Mikko, from a use case perspective, what are you seeing as some of the leading use cases, both in the maritime industry but other industries, where you're seeing a lot of traction and adoption? Clearly, some of it is around device connectivity, yes, and data. But there's a lot of buzz today around Gen AI and how that's transforming enterprises, and I wonder if you're seeing use cases in that mix of AI and operations and networks.
Yeah, some of the leading use cases, first of all, in the maritime industry, autonomy or remote control or remote mooring of the ships is a use case we enable through program specialized networks. So this will save money for getting the pilots, I think they're called pilots, onto this. Instead of getting them onto a ship to moor into difficult kind of a harbor, they can be actually taking remote control and awareness and manage that dangerous operation safely from a remote operation center. That's one of the use cases. Then the other use cases I mentioned already is the sort of supplementing autonomy, for example, if it's self-driven cars or remote-driven cars or so forth, so ensuring that those have the necessary connectivity and understanding of the network to support the operations. And we actually seen what happens when the trust in the network breaks down. We have a traffic jam being generated when the autonomous cars, get stuck into a road because they cannot get connectivity or so forth. Then on the generative AI use cases, if you think about where generative AI is being inferred, where the models run, you need generally quite a lot of computation. So that one is much more centralized. So there is a need with the high quality to assure and ensure that the data from the device get into the inference from the model. So again, the network plays a crucial part in that. We could say all over, while we don't usually realize it, but the trustable quality network is underpinning all the applications, and all the applications that we use are massively distributed, connected together, across the network. So, so we'll see use cases coming up from sort of all facets of the industry digitalization.
Yep. And what's fascinating about that is when the cloud first started, we all thought this is great. We could kind of run our apps in the cloud, and this will be fantastic. I was part of Microsoft at that time. I don't think anyone anticipated what the cloud has become today. If we go back in time to the early hype cycles, David, of 5G, there was a lot of noise, and maybe Hugh, you heard this as well, that cellular is going to replace Wi-Fi. I don't necessarily think that was the case. It certainly isn't the case now, but I'm curious to get your perspective on what is the role of cellular versus Wi-Fi in the enterprise? What are you all seeing there?
That's pretty interesting. I think we also thought initially that this would replace, Wi-Fi. It's not the case at all. I remember years ago seeing a discussion in the utility industry where they said they have 13 identified use cases, and all 13 of them could fit. They were all operated in different silos with different technologies, and all 13 of them could be supported with just private LTE. So from a support services perspective of a large utility, they thought it could replace Wi-Fi. Fast forward now, I think it's definitely not an either or. The perception that's replacing Wi-Fi is not the case. Wi-Fi is an appropriate application for many challenges, whether it be regular office applications or regular IT types of applications. And Wi-Fi is getting better also. I mean, Wi-Fi 6, Wi-Fi 7, it solves some of the problems of throughput and latency that private cellular is better at. Private cellular can penetrate more walls. It does have significantly greater coverage and latency and mobility, concurrent connected devices. There are certainly some things there. What we've been working on is rather than the either-or aspect of it, but trying to help our partners to use the right tools to solve the right problems, and maybe how can you get even more clever and combine the tools. So as a specific example, we have a technology called MX Boost, and what it does is it replicates the Wi-Fi data stream and the private cellular data stream from the same machine. So if you want to have high reliability, you have a replication of the data stream, and if you want to have greater throughput, you can have an aggregation of the same data stream. So use both technologies at the same time. Don't choose one or the other necessarily, but maybe use it more intelligently.
Yeah, interesting anecdote. One of our partners in the lab is the largest producer of asphalt shingles products here in the United States and globally. And they did an assessment. They wanted to cover 80 acres of a yard after they completed manufacturing the shingles. They put them out in the yard. And so they did the assessment of what the coverage would be like, and how much it would cost with Wi-Fi. It was $3 million. Then they did the assessment on private wireless, and it was less than 200,000. So that's kind of where the trade-offs really play out.
Absolutely. Just to add to that, it's counterintuitive. People think because private cellular is new, that it's going to be more expensive.
Right.
But again, depending on the use case, if you're talking about an outdoor coverage in Hugh's industry, you're talking about putting an access point, a Wi-Fi access point on every single pole, having a refresh cycle every 3, 5, at most 7 years, putting more fiber in every single time.
Right.
The costs of it are extremely higher than a private cellular network.
Besides, they are not sending the Wi-Fi systems to the moon, but it's the private wireless, which I think on the next Artemis mission there will be Nokia moon network available.
Legit, there's a 4G LTE network operating on the moon. That's
right,
Nokia's. Yeah. Fantastic. Who'd have thought? Harri, so coming back to the telcos, there's been a role that they have been exploring relative to what role they want to play in private 5G networks. And we've seen everything from dedicated private 5G networks to slices and some permeations of different strategies in between, like licensed spectrum leasing and other things. I'm curious to get your perspective on the current play with carriers today vis-a-vis the whole private 5G opportunity. Where do you think that's going longer term?
Yeah, so there's a lot of potential here because so far, if you look at telcos or carriers like T-Mobile, Verizon, AT&T, they have been providing connectivity, mainly for consumers and for enterprises, but providing just connectivity. Now there's a potential to get more market here by providing reliable communication for the critical applications. They also can provide some new applications. They can provide the edge cloud. So there's a potential to get part of the new market segment and some new products and some new also hardware deployments. And also, I think carriers remember that they have some assets, some critical assets that are useful also for the industries. They have spectrum. Of course, we can use also the shared spectrum, but carriers do have their licensed spectrum, which may be also valuable for the critical communication. Secondly, carriers have also the competence in designing and operating the networks. If you want to have a reliable connectivity, it's not only about technology, but it's also how to deploy, how to operate, and how to manage that. So that is one role where the carriers may be important here. And also, we already mentioned the interworking between the local network and the wide area network. And there are some good examples. I will take one example from the home market in Finland. There's a fairly large private network in the mine in the northern part of Finland. And that private network is several hundreds of 5G cells. The motivation for that is that the mining company can have remote controlled machinery on the ground and underground. And if you can do that with the 5G connectivity, you can imagine a lot of improvement in the productivity and also safety, because you don't need to have anybody underground. That specific solution, the technology is provided by Nokia. The spectrum is provided by Telia. Telia is one of the telcos in the Nordic market. And the network is operated by a third company called Digit. Another example that was on the news last week is also Tesla is now using 5G for their Gigafactory in Berlin. And the motivation for Tesla, they indicate, is that 5G can provide reliable communication not only inside the factory, but also in the premises around the factory buildings.
Yeah, absolutely. Now, we've sort of danced around the importance of data and why these networks are so critical. Edge computing, Hugh, has been kind of talked about for the last, I would say, 8 to 10 years. Gartner last year predicted that 75% of enterprise data will be developed outside of public data centers, public cloud data centers, and private cloud data centers. You did touch upon the importance of data. I'm curious to get your perspective. Now that you have cellular networking and access to a lot more data, how are you making sense of that? And how important is edge computing going to be for you to not only generate that data, store it, but process it and maybe even make real decisions real time on it?
I think it's becoming fundamental to the business. We have stood up, invested quite a bit in our data science teams and our data analysis capabilities just to sift through the data. And we're kind of seeing a flywheel effect where even groups that weren't involved in the initial initiatives are saying, hey, we've got reporting or analytics use cases that we want to use. And so it's really tying the whole company together. And we're a little bit unique in that historically the company's been very federated, and regional in nature. And so it's been kind of a game changer for us in terms of getting access and centralizing all of that data and putting a team and technology on top of it to really understand where the value is and how we can leverage it. So we'll see, but it's kind of central to our technology strategy at the moment.
Someone once referenced that data is the new oil, and it seems like that.
Yeah. We were throwing that around a couple of years ago. Absolutely, it's definitely the new oil or the new the new hot commodity for sure. So.
Absolutely, and it's a differentiation. Mikko, last question for you, my friend. There's been a lot of effort from Nokia, obviously, in the network as code approach, but Nokia is also introducing some edge computing capabilities as well. I'd love for maybe you all to touch on what those capabilities are and why it's important going forward.
Well, the edge computing capabilities are important in optimizing how workloads are placed, when application workloads are placed, and how the data streams are actually going in the network. Going back to the example of the bytes going when you do a Google search on a device through Nokia equipment. Sometimes they don't go all the way to the cloud. They need to be processed very near to the application. By the way, Harri just reminded me one of the application which is in very large indoor warehouses using mobile connected drones to do inventory of the warehouses. So you save a lot of money because instead of there's a manual inventory done using ladders, you have a very small drones which go and scan all the packages and their barcodes. Now, that drone is communicating only with an edge computation capability, which then provides the drone, based on the drone cameras, its visual positioning. So the drone knows how to navigate through the warehouse. In that kind of a scenario, it's very important, first of all, that the positional input to the drone comes with a very low latency, so you have to have the edge computation near the drone. But also predictability of the network is important as well. So if there's any variance in terms of the latency, meaning there is a jitter in terms of how the packets are being transferred into it, the drone positioning, visual positioning goes off. So that's one example how and why sometimes we need to do the computation in very near to the actual devices and an application, and one justification for the edge cloud. The other reason is for, of course, security and ensuring that the data doesn't go into where it shouldn't be going. Data sovereignty is one of those reasons as well.
Last question, Harri. I think we're up to, 4 billion connected devices in the world today, a mix of 5G and 4G LTE devices.
It
and
is
billions-
5G is already more than 1 billion, so 4G even more. So yes.
Yeah, billions more of IoT-connected devices. I was going to ask about the carrier's role in Edge, but now there were 11 seconds left. I don't think we'll give you the proper time.
Go.
Skirted by that one. Too bad. Anyhow, I wanted to thank you all sincerely for your time today. Harri, thank you again for joining us all the way from Finland. Mikko and David from coming up from the Bay Area. And then obviously Hugh for taking time out of your busy day to share your insights and perspectives. We all really appreciate it very much. Thank you all.
Thank you.
Thanks, you guys. Awesome. It's one of these things you start to take for granted, until it's gone, the network everywhere. Okay, we're going to steer